Ever wondered what actually happens in that split second between typing a website name and the page loading? Welcome to episode 5 of Networking Explained, where we unpack DNS, the domain name system. Think of it as the phone book of the internet, the quiet service that turns a name like Dargslan.com into an address your computer can actually reach. So here's the core tension DNS exists to solve. We humans are wired for words. Something like Dargslan.com is easy to remember, easy to share, easy to type. Machines, on the other hand, route traffic using numeric IP addresses like 192.0.2, 146. Nobody wants to memorize a string of digits for every site they visit, and that's exactly where DNS steps in, as the quiet translator sitting between the two. So if we had to capture it in a single sentence, it's this. DNS is the system that translates the domain. Names people type into the IP addresses machines actually connect to. You hand it a name, it hands you back an address. And there are 3 small details worth holding on to here. It's not one giant master list somewhere. It's distributed across many servers, and the answers get cached along the way to keep everything fast. To make all of that feel a little more concrete, think about how you actually contact a friend. You know their name, but you probably don't have their phone number memorized. So you open your contacts, look up the name, and out comes the number to dial. DNS plays exactly that role for the internet. The domain name is the friend's name. The IP address is the phone number. DNS itself is your contacts list, and the act of asking is what we call a DNS lookup. Now, a lookup isn't handled by just one machine. There's actually a small cast of characters working behind the scenes. First, the recursive resolver does the legwork on your behalf, usually run by your ISP or a public service, like 1.1.1.1. It starts by asking a root server, which knows where every top-level domain lives. The root points it to a TLD server, the one responsible for .com.org or .cu. And finally, that hands off to the authoritative server, which holds the real answer for the specific domain you're after. Let's watch that play out for Dargslan.com. You ask your resolver, which then walks down the chain. First, checking with a root server, which points it toward the .com TLD. The TLD server says, here's where Dargslan's authoritative server lives. And that final server returns the actual IP 192.2.146. And here's the nice part. Your resolver remembers that answer, so the next time you visit, the whole journey is skipped and the reply feels instant. That remembering is the real secret behind DNS speed. Catching happens at every layer. Your browser holds onto recent lookups for a few minutes. Your operating system keeps its own cache just below that, and your resolver stores answers shared across thousands of users. How long each entry sticks around is decided by the TTL, the time to live attached to every record. More caching means faster browsing, but it also means changes take longer to propagate. That's the trade-off baked into the system. Now, those records I keep mentioning, let's actually meet them. The A record is the classic one, mapping a name to an IPv4 address, while A does the same job for IPv6. CNAME is an alias, pointing one name at another, which is handy when you want several host names to follow a single target. Then there's MX, which tells the world where email for your domain should go. TXT, a freeform field used for things like SPF and domain verification. And NS, which declares the authoritative servers for the zone. 6 small building blocks, and together they cover most of what DNS does day to day. And the best way to really understand these records is to ask for them yourself. With Dig, you can request just the answer using the plus short flag. Here, Dargslan.com resolves to an IPv4 address, and adding MX shows where its mail is routed. The older nslookup tool does something similar, and even tells you which resolver answered, in this case, Cloudflare's 1.1.1.1. Try these on your own domain. It's the quickest way to see DNS working in real time. Now, let's zoom out and see where DNS actually sits when you load a web page. Before anything else can happen, your browser needs an IP address. That's the DNS lookup. Step 0. Only then can it open a TCP connection to that IP, negotiate a TLS handshake to encrypt the channel, and finally send the HTTP request for the page itself. 4 steps in order. And if DNS stalls, the other 3 never even get a chance to begin. Now that we've seen where DNS fits in, let's clear up a few myths that trip people up. First, DNS isn't one giant server in a basement somewhere. It's a distributed hierarchy spread across thousands of machines, with no single one holding the full picture. Second, changes don't propagate instantly. Because of caching and TTL values, an update can take minutes or even hours to ripple out worldwide. And third, classic DNS isn't secure by default. It's sent in the clear, which is exactly why DNSSEC, DOH, and DOT were created. Let's zoom in on that second myth because the word propagation is genuinely misleading. When you update a record and the old value keeps showing up, nothing is actually traveling anywhere. Resolvers around the world are just still holding the previous answer until its TTL runs out. So the trick for a smooth change is simple. Lower the TTL hours in advance. Make your edit once that short TTL is in effect, and then raise it back up once everything looks stable. That same caching trust, though, is exactly what makes DNS a target. Classic risks include spoofing, where an attacker sends back fake answers, cache poisoning that plants those lies inside a resolver, and the simple fact that plain DNS is unencrypted, so anyone on the path can see every site you look up. The defenses match each risk. DNSSEC cryptographically signs answers, so forgeries get caught. DNS over HTTPS and DNS over TLS encrypt the queries themselves, and choosing a trusted resolver like 1.1.1.1 or 9.9.9.9 keeps your lookups out of less reputable hands. So who actually runs all of this machinery behind the scenes? There are really 4 players to know. Registrars are where you go to buy a domain name. Think GoDaddy or Namecheap. Registries sit a level above them, operating entire top-level domains like .com or .hu. DNS hosts run the authoritative servers that hold your zone's records. And finally, public resolvers, the 1.1.1.1s and 8.8.8.8s of the world, answer lookups for anyone who asks. Now that you know the players, let's talk about the tools you'll actually reach for. Dig is the Swiss Army knife for DNS queries, while nslookup gives you quick lookups on just about any operating system, and Host keeps things to a simple one-liner. For resolvers, Cloudflare's 1.1.1. and Google's 8.8.8.8 are the go-to public options. And when you want to see how a change is spreading across the globe, dnschecker.org shows you propagation in real time. So let's pull the threads together. At its heart, DNS turns human-friendly names into machine-friendly IP addresses, and it does that through a distributed hierarchy. Not one giant server, but many working in concert. Every lookup walks the same path. Your resolver checks with the root, then the TLD, then the authoritative server, with caching and TTLs keeping things fast, even if updates take a little time to spread. And remember, DNS happens first, before TCP, before TLS, before HTTP. It's the quiet first step behind almost everything you do online. Now, if you're the one actually managing a domain, a few small habits go a long way. Before any planned change, lower your TTL ahead of time so updates can propagate quickly when you flip the switch, and never crank TTLs up right before a migration. Choose a reputable DNS host. Enable DNSSEC if it's supported, and don't lean on a single provider as your only point of failure. And maybe the easiest one to forget, keep an eye on your registration dates, because letting a domain lapse can undo years of work overnight. If this sparked your curiosity, there's a whole Networking Explained series waiting, covering TLS, load balancers, reverse proxies, and CDNs, each one building on what you've just learned about DNS. And remember, DNS only gets people to your server. What happens once they arrive is a different battle. That's where SSH hardening mastery comes in, over at dargslan.com/courses. Before we wrap up, I've got a quick question for you. Which DNS resolver do you actually use day to day? Maybe it's Cloudflare's 1.1.1.1, Google's 8.8.8.8, whatever your ISP hands out, or something a little more private. Drop it in the comments. I'm genuinely curious what this audience runs with. And that's DNS, the quiet translator making the whole internet feel human. If something finally clicked today, hit subscribe and stick around for the rest of the Networking Explained series, where we keep pulling back the curtain on how all of this actually works. You can find more over at dargslan.com. Thanks for watching. I'll see you in the next one.